So factored form. And the advantage of being in factored form is you can identify, instead of identifying the vertex, like our last problem, we can easily identify the X-intercepts. So in factored form, assuming we haven't done bottoms up and push the number up, so it's just a 1x, the opposite of this number will tell us exactly what the X-intercept is. So go to, you have this graph, it's number 3 in your class notes, go to -4 and +2 and make your dots. So if somebody said to identify the X-intercepts, it would be -4, 0, and 2, 0. And I want to reiterate that we can do this when it's in factored form and we have not done bottoms up, so we have not pushed a number in front. Like right now, if you're like, I don't really understand what she's saying. If I gave you this form like this, remember how bottoms up, it can't be reduced, we'd push the 2 up? Remember doing that? Don't push up. Don't do the bottoms up part. Leave it in this form, and then you can easily identify the X-intercept. So I circle it. The opposite of +4 is -4. The opposite of -2 is +2. Done. Okay, now here's your next thing. We have to figure out the distance between these two. Now, some students are like, oh, that's not hard. 1, 2, 3, 4, 5, 6. Okay, great. But if it was fractions, it may be a little bit harder. So we're going to pretend this was harder than it really is. We're going to type in the larger of the two numbers, 2. And we're going to subtract, because we're finding the difference, we're going to subtract the smaller number. And we get an answer of 6. Now, yes, could I see that by just looking? Sure. But in other problems, there may be fractions, and it's not as easy to see. Okay, so we have 6. Half of 6, because we're going to split that difference in half, just like we split a parabola in half to make it symmetrical, and we get 3. So from either side, I want you to move in 3. You'll end up at the same point. So 1, 2, 3. And then identify your axis of symmetry or your line of symmetry. So I found the difference in between them, and I cut it in half, and then from either point, you move in that amount. Identify the axis of symmetry. Okay, now we need to find the vertex. That's our next step. So I have the axis of symmetry. Sometimes it's called line of symmetry. Now I want to do the vertex. So I know the vertex will have an x value of -1. Go back to the original equation, and we want to find the y value. Wherever I see an x, I substitute a -1 in. And do the math. -1 and +4 is 3. -1 and -2 is -3. Don't forget about the negative sign out front. And when you multiply 3, you end up with a +9. So along the axis of symmetry, go up 9. And make a dot. So we've identified the vertex, the axis of symmetry, the X-intercepts. I have one more thing I want us to identify, and that is going to be the Y-intercept. Now here's how this works. Recall that when I give you something like this is a different problem, and I would ask you, what is the Y-intercept? The advantage of standard form is the Y-intercept stands out as the last number, right? Yes. Has no x involved. Well, we can easily identify that by doing the following. I'm going to highlight the number that's in back of each parenthesis and whatever's out front. If you multiply those 3 things, remember to do the sign in front of each, and what's out front, you'll end up with the Y-intercept. So here we go. Negative, +4, -2. The Y-intercept for this problem is 8. So Y-intercept is 0, 8. So go up to 8, 0, 8. And here's why symmetry is kind of cool. You get to cheat. So I know if there's a dot here, and it's 1 step to the right of the axis of symmetry, I could get to go 1 step to the left of the axis of symmetry and make the same dot on the same level, on the same horizontal level. Okay, connecting please. Connecting back and including arrows. So let's analyze this, and then we are done. First one is domain. The domain, no limit how far it goes to the left or right, so it's negative infinity to positive. The range, there's no limit how far down it goes, negative infinity, that one must go first, and it goes as high as a y value of 9. We have to include that 9. From left to right, it increases and then it hits a turning point. So remember, as you're going down, it's also being pulled to the right. And as you're going down on the right, it's also being pulled to the right. Being pulled to the left and right as you go down. So, for increasing, it comes from an x value that has no limit to the left, and it continues to increase until it hits this turning point. Whoa, but it always has to be in terms of x values. -1, great. Remember, increasing and decreasing only have parentheses. Decreased, it starts at the turning point of -1, and there's no limit how far it goes to the right. And our final is going to be end behavior. Regardless if I analyze this from the right or from the left, in both situations, the end behavior is going down.